Good morning. My name is Stephanie Smith. I'm going to start by saying I'm going to beg your forgiveness. I'm fighting a little bit of a cold this morning. I'm hoping I'm going to make it through the whole webinar, but we'll see how this goes. I'm with Risk Management Professionals. Our producers, Kevin and Vincent, are here and will be keeping us running and taking questions as we go through the material. Since this is pretty much going through the standard for the IIAR Standards step by step, if anyone has any questions while we're talking about a topic, I'm happy to take the questions as they come up. Just try to convey that in the dialog box. I'll go through the question and answer in just a minute. Our number here is 877-532-0806. If you have any technical difficulties, we have people standing by to help. And you can adjust the viewing screen with the video of myself talking and the PowerPoint presentation by moving the slide bar between the two images. The dialog box for questions is located on your screen in a little pull-down menu. Feel free to submit any questions in the question box. I'll save most of the stuff for after the presentation if we can. However, if there's something pertinent, I've asked our producers, Kevin and Vincent, to kind of flag me to take a question while we're discussing a topic. I feel like with the just the kind of mundane nature of going through standards sometimes, it'll be helpful to kind of break that up if we have questions that come through. Excuse me. So this webinar series is part of our ongoing outreach program. Our core competencies and expertise are in the EPA RMP, the OSHA PSM and CalARP standards, SEMS program development, HAZOP and LOPA studies, and other hazard identification techniques, and a variety of other process safety and regulatory standards and regulations. Basically anything you can think of, we could probably have someone around or resources around that can make that happen for you. Today we're going to talk about the IIAR standards and how they apply to RAGAGEP. Again, I kind of started talking about how I'm going to go through the standards pretty step by step. They're not too new. We're talking about 2012, 2014, but these standards resonate from the old IIAR bulletins that are still out there and still published, but they're trying to move everything over, and until everything's moved over to the standards, the bulletins are staying active as well. So you kind of have this dual requirement. However, the standards really are what industry is taking as the go-to for ammonia refrigeration, and in essence of that, probably applying to other industries that use ammonia as well if there's not an agency that's publishing standards. So it's really important to remember that. There'll be a lot of different parts with this, and we're going to spend a lot of time going through this over the next 6 months to a year. So I'm going to go ahead and go through an introduction, what RAGAGEP is, and where those sources are for various industries. Again, we're focusing on IIAR today, but there are other industries and other references that are available. We're going through the IIAR Standard 1 that was developed in 2012, mostly just definitions, but they're important for the rest of our discussion through the presentations that follow. And also, we're going to start on IIAR 2, and I believe we're making it through all of Chapter 5. We'll go over the overview, and I'll emphasize RAGAGEP for existing facilities as they apply to system improvements. So we have the standards that really apply to a new design, and then we have the RAGAGEP that's kind of pulled out of these standards and interpreted to apply if you're doing equipment upgrades, updates to the system, replacing things, or just general safety you may not already have. That's where we're going to talk a little bit more about the RAGAGEP, but I felt it was a good overall view to talk about all the design standards in case someone missed something somewhere. It's always good to go back through this stuff again. There are 8 standards right now. Standard 6 is the only one not published. However, last couple days I checked, they're also going to publish a 9th standard that will be focused on RAGAGEP guidance. This is something that's new to my knowledge in the last couple months. That will help and balance out our discussions here and probably bring out what's really important for RAGAGEP for those existing facilities. Again, we're going to go through this whole thing. We're going to talk about it from a design standpoint, talk about it from beginning, start to finish, but we're going to try to focus on RAGAGEP a little bit, and it's a good way to just get a better idea of what might be missing at your facility. Introduction. So I just listed out the the regulations that call out RAGAGEP and CalARP, RMP, and PSM. CCPS has a definition as well. They're, to my knowledge, the only group that has a definition for RAGAGEP. But I wanted to list these standards so that someone could reference these if need be. I won't go in the nitty-gritty, but every single standard out here is calling out the need for RAGAGEP at facilities. RAGAGEP stands for Recognized and Generally Accepted Good Engineering Practices. It not only applies to the design of the system, but also practice and implementation at the facility and the safety culture that's there. There's a lot of segregation between the two sometimes, and it really shouldn't be. It's all-encompassing. It should apply every day, and it's a way to just have a safe practice at your facility. I put the definition for CCPS here. I'm not going to read it, but again, it goes through everything from the design to practicing, maintenance activities, using codes to design your system appropriately. So it covers both sides of that same coin. For sources for RAGAGEP, they're basically published in accepted codes that would be like the federal, state, or municipal jurisdictions like building codes, NFPA. Usually start at the local level and work your way up to federal, since local has better jurisdiction. Then you move on to the published consensus documents, and these are listed in the order that they should be used as far as authority. There are broader guidance manuals, but as requirements and guidance gets more detailed, that's what really should be used. So these published consensus documents come from organizations that are represented by committee membership. So IIAR is a perfect example, ASME, ANSI, READ is another one that comes to mind. Any standards or guidance documents that are published, that's where these would fall into for organizations. And then there's non-consensus documents. So they're smaller organizations and more focused on a specific industry, usually smaller organizations, the Chlorine Institute pamphlets. CCPS publishes a number of guidebooks. Any kind of peer-reviewed technical articles might be like a case study or something from a larger company. Things like that kind of bring in RAGAGEP and are important to keep track of. So we're going to talk about ANSI IIAR 1 that was published in 2012. I'm only outlining the more important definitions. There is a full list of definitions in the standard. I encourage you to have that handy if you're looking through anything else for definitions. It's not really necessary to read through the whole thing just to know what the definitions are, but if you ever have any questions about how something's defined, that's where you're going to find it. It should be expected that all the definitions will move into this first part. There are still, each of the standards still has their own definition section at the beginning. However, it looks like they're going to start moving everything to one section, the section 1, and remove the definitions from the rest of the documents. So this will be your place to go to. This is your dictionary for the standards. So we're going to take the definition, we're going to take what's required, and we're going to talk about, in this whole process, we're going to talk about how do you implement all of this. So emergency operating procedures are intended to be used under abnormal, unintended, or time-sensitive conditions. They may involve risk to health, the welfare of operators, employees, or the public, and include any of the components of the refrigeration system, or may include hazards of the product. So it's important to remember that the emergency part of that, it goes broader than just maybe immediate need. It's really talking about the hazard and the fact that it's a very large hazard to in a broad range of or broad spectrum of things that can happen. Machinery room is defined as an enclosed space that houses equipment. That includes compressors, pumps, liquid transfer equipment, equipment that raises the pressure of the refrigerant. And again, this is all defined in the first standard, Standard 1. One really important definition is monitored. This is something that can be interpreted different ways, and so they've really spent time to define it, and also I have a little bit to add on to that. But monitored is a means of continual oversight, such as notification to on-site staff, third-party alarm service, or a responsible party. This means that an auto dial or a pager number may not be enough to be a monitored number. It needs to be a 24/7 number that someone is going to answer. It can't just be a message service or something like that, and it's really important to remember that when we're talking about these standards, that monitored is kind of taking this whole new meaning and they've actually defined it, that it has to be an answered call, wherever or whoever that may be. Piping is referred to as interconnecting parts between the equipment and in the system. Pipes, flanges, bolting, gaskets, valves, fittings, you name it, it's there. So anything that's not what you consider your big pieces of equipment is considered piping. Okay. Okay, we have some additional information from Tony Lundell. Okay, so the title for the Standard 9 I was discussing a little bit ago may change to application of RAGAGEP or to sustain RAGAGEP, sounds like. So they are still under a working title. That information is available on IIAR, the website, but it is important to note they are still working on it and going through it. I believe it's going to go for public comment soon, so that's something to keep in mind, and thank you for that information. So going back to definitions for readily accessible, basically that means that you have to be able to access the equipment without the assistance of some kind of access equipment, so like a ladder or something like that, and you cannot require someone to like climb over something or have an obstacle in the way. So readily accessible really means that you can just kind of get at the equipment, whether it's a control box or a compressor, whatever it is, nothing can be in the way, no ladders, if it's a built-in ladder, something can get up to a loft-type area, that is deemed acceptable. But anything portable that you need to move around or whatever, so when the standard says that something needs to be readily accessible, that's really what they're referring to, is that nothing is in the way. It's ready to go. Another definition really important is shall or shall not. I know Rita spent some time on this as well, discussing it in some of their bulletins, and also should and should not. These both really refer to what is mandatory versus what is recommended good practice. So it's important to remember the definitions of these terms and that there are minute differences, but they do hold a defined importance in what's actually required versus what's recommended. For temporary operating procedure, again, this is one that's kind of left to interpretation, and the procedure involves a deliberate and planned operation, so it would be like a turnaround type situation, but it refers to anything outside of the normal operating range and includes specific steps that need to be taken so there are no safety ramifications. And that's really important to remember, is it's all about safety. Excuse me. I also want to call out the difference between a trained startup technician and a trained technician. It is possible to have someone trained in both. However, it's very important to realize that a startup technician may not be qualified, or a regular technician may not be qualified as a startup technician if they're not trained appropriately. The standard calls these out specifically for a reason, so to avoid confusion. And again, it's possible that someone could be trained in both, but it's important that if you have a startup technician and a maintenance technician, they're both trained appropriately. So we'll move on. Those are the important definitions from Standard 1. Standard 2, again, I'm going through Chapter 5. The new things to note about this standard is that Chapter 2 of Standard 2 has fewer definitions than the previous edition. Again, this is going back to them moving the definitions from the individual standards into Standard 1 and having a definition standard. Chapter 4 is new for this edition that was published, and Chapter 5 was updated for new design standards and best practice. Again, that's why I wanted to go through it. I'm not really sure the numbers as far as how many new systems are being designed. However, those same principles and applications can be applied to new equipment, upgrades to systems, or if you're just in general missing something that may be easy to fix or replace. So Standard 2 is designed for safe design of closed-circuit ammonia refrigeration systems. The partial purpose was to update compared to ASHRAE Standard 15. to meet NFPA codes, the Uniform Mechanical Code, and the International Mechanical and Fire Code. So to be able to integrate all of those codes together and meet all the standards. And again, we discussed through Chapter 5 on this one. So what's new? This was published in 2014. They are now referring to these as standards. Again, like what I said probably about 10 minutes ago, is that the bulletins are kind of being phased out and these standards are being put in place. Both are still on the table, but the bulletins, the information from the bulletins are now being put into these standards and then developed and updated appropriately. These standards are referenced in the International Mechanical and Fire Codes as the authority standard. They are referenced in OSHA and EPA as a standard. And Appendix A also provides more information in Standard 2 for certain topics. In the standard, those topics have an asterisk next to them, and then there's a whole bunch of explanation in the back, usually referring to calculations or when there may be some interpretations needed. The EPA enforcement alert from February 2015 also refers to the IIAR updates as the industry standard. Again, like I said, Chapter 2 has some definitions. I want to cover a couple of those. Most of them are moving into that first standard. And I'm skipping Chapters 1 and 3 because they're really just general information about the standard and some background information. There wasn't really much there that I felt was pertinent for this discussion. They are available to read and look at if you need to. So Chapter 2 defines authorized personnel as someone who has been specifically granted permission to enter a restricted area. And it's important to remember that there are discussions based on someone who's authorized to enter a restricted area, and that's where this definition really comes into place. You can't just have anyone, even at the facility or off the street, coming into your facility and just walking in the machine room doing whatever they want. You know, to be able to lock these doors, put the correct signage on things, that's where the standard is kind of going into, and this is one of the definitions that's really important for that. And equipment also is, I just want to bring that up, that's an assembly, a sub-assembly, an accessory, or component of the refrigeration system. So any part of the system is considered equipment. A package system is a prefabricated or pre-assembled closed-circuit system. It should contain all essential equipment, piping, and devices that are needed to run that piece of equipment. It could be enclosed or unenclosed, but again, they've defined this in the standard to make sure that everyone understands what a package system means by the standard. Again, restricted, going back to authorized personnel, the restricted definition describes an area that is permitted to be accessed by authorized personnel only. So not just public access, it can't be accessed, it's usually a locked or alarmed door, requires special access by key code or a key fob tag or whatever it is, more security. And that's really what they're emphasizing, is that additional security for pertinent equipment that could cause a lot of damage or a lot of hazard at a facility for someone who may not know what's going on. Like I mentioned before, Chapter 4 is new, so I'll spend a little bit more time on this in these next couple slides going through this. Chapter 4, for the location of the machinery, basically all the locations should comply with Chapter 4 as far as locating machinery, which also carries into complying with Chapter 6. Chapter 6, which we won't go through today, but I'll give you a brief overview, goes through many pieces of equipment and where the locations for specific equipment are. So you're talking about compressors or evaporators, pumps, things like that. So unless it's exempt by 4.2, which we'll go through in the next little bit, you must comply with Chapter 6. And again, we'll get to that in the next part of this series. So this should be kept in mind for equipment upgrades, that some equipment can be housed like outside the building. And they do give you some standards for that, and that's going into Section 4.2. That equipment includes evaporators, condensers, low probability pumps, valves, and compressors that do not exceed 100 horsepower. So if you have a low horsepower piece of equipment, you can put it outside for an industrial occupancy. For a public assembly, commercial, or mercantile occupancy, you can allow for machinery outside if the complete discharge of ammonia will not exceed 300 ppm. So if you have a relatively small system that even if you discharge the entire volume from whatever piece of equipment we want to locate outside, if that high target concentration less than 300 ppm, you can locate that outside, given you meet the occupancy categorization here as well. With those exceptions, if there's equipment outside, they cannot be installed within 20 feet of a building opening. And again, we went through that certain types of equipment outside. So for smaller systems, maybe upgrading to fewer pieces of equipment, downsizing a facility, building a new facility that may be a little smaller. These are things to keep in mind is that there's some piece of equipment that can be located outside, maybe save you some room inside for a facility and warehousing. Chapter 5, the general system design requirements, is going to be the rest of our discussion. And again, we're going through Chapter 5, and we'll stop there. It's plenty of information for this morning. I'm hoping you guys all had your coffee, because it'll take us a little bit to go through. But I'm going through this basically section by section. I'll kind of cruise through some of the easier sections, or ones where you just kind of have to look up the information in the standard. Other ones I'll spend a little more time on. So section 5.1 is just talking about how the ammonia refrigeration system has to comply with this chapter. Section 5.2 talks about the specifications for ammonia. So it talks about purity, quality of ammonia, and how, what's required to use in a closed circuit system. Section 5.3 is discussing the calculating the concentration for ammonia release. So those additional subsections, 5.3.1 through 5.3.4, talk about guidance on wall openings, suspended ceilings, interconnected floors, and ventilation considerations. And if I remember correctly, this is also a section marked with an asterisk. There's more information in Appendix A. So if you're doing these calculations, this is where you want to go. Or if you want to verify any calculations, this is where you want to go. Section 5.4 talks about secondary coolants. That they can be used with these systems as long as they are indirect closed system or double indirect open spray system. And again, those definitions are also in this in these standards. I just didn't call those out. That's a pretty general requirement. Section 5.5 starts talking about system design pressure, and the first subsection of that's just general information. So it talks about the allowance for setting pressure limiting devices. And pressure relieving devices to avoid shutdown. So you don't want to set your pressure relief at the same set point that your equipment's rated at. That's kind of what this is getting at. You want to give yourself an allowance there so that that PRV is going off before you lose your equipment and damage it. That's the whole intention of these standards, is safer operation. All equipment should, in connection with each other, should be designed at the same design pressure or greater. So everything needs to be, basically they're trying to eliminate a lower design pressure unintentionally, or an area where you may lose a piece of equipment and have a weak spot. Excuse me. Compressors used as boosters are considered part of the low pressure side. And they wanted to define this to be able to make sure everyone's on the same page for design standards. Low pressure equipment must equal the design pressure of the existing low pressure side. Again, you can't bring something that's rated lower than an existing piece of equipment. Everything should be on the same pressure rating, or basically at the same safety level that the rest of the system's at. Section 5.5.2 talks about how to determine what the maximum pressure, the maximum design pressure is. Basically, you're looking at the operations pressure, or pressures during operations, pressures during a standby situation, and pressures during shipping, if there's anything shipped within the unit. Taking all that into account, that's where you really find your maximum design pressure. So I put the actual statement here from the regulation. This includes any of these, excuse me, any of these conditions may include like fouling of the heat exchange surfaces, where you may see additional pressures. It could be conditions in the system may not be in operation. Again, you're talking about standby, maybe a turnaround where you have higher pressures somewhere in the system. Also looking at the highest temperature of exposure. If you have piping on a roof or equipment outside, it's raising the temperature of that ammonia possibly, or maybe you have another area where there's high pressure and high temperature of ammonia. You need to take into account all of this information, and then maximum design pressure should come from all of that information put together. The design pressure shall meet the following requirements. I won't read through this. I put this here so it's an easy reference. But basically going through low side and various high side requirements as far as where you get your design pressure from at minimum. So not only do you look at this, but you also look at where the operation levels are. You're kind of taking a lot into account and making sure that, again, everything is in safe operation. You're designing your system to withstand all the normal conditions, whether it be temporary operations or emergency shutdown or whatnot. All the conditions that could happen and that system could be considered quote-unquote normal to be able to use that maximum design pressure to make sure everything's going to run okay. And equipment shall be designed for 29 inches of mercury as well. Section 5.6 talks about the equipment should be designed for a full range of temperatures. This includes system and ambient temperatures. Again, going back to equipment outside, piping on the roof, perhaps you're an ice cream facility and you have freezing conditions inside. All the highs and lows, wherever they may be, wherever your system's exposed to, they all need to be taken into account. For materials, it specifies that any materials used in the system should be suited for contact for ammonia. That kind of goes without saying, but again, they've defined it here. And also that that materials that deteriorate in the presence of ammonia or oil should not be used. Again, going back to just safer operations to make sure all the checks and balances are there. And I know these systems are pretty standard and everyone uses kind of the same thing, but again, going through and making sure that everyone knows what's required. Sections 5.7.2 and 5.7.3 talk about the acceptable and non-acceptable metallic and non-metallic materials that you can use. It's a semi-general list. There are some specifics. I didn't want to list everything here, but they are available to look at if needed for equipment upgrades or whatnot. 5.8 talks about the ability to purge non-condensable gases from the system. Again, a lot of facilities are already taking care of this. This could be an area of RAGAGEP if you don't already have a means for whatever reason. It does not specify what means. However, that may be covered in a later chapter. I haven't quite got there yet. But it does say there has to be a means to purge the gases. For oil management, there must be a means to remove oil. The compressors should have a means for sampling oil. The oil removal can be accomplished by a number of ways. It could be a rigid oil piped return or transfer system, vessel equipment with a shutoff valve in series with a self-closing shutoff valve, or a valve and piping assembly at the draining point with a shutoff valve in series and a self-closing shutoff valve. So basically having your shutoff valves, dead man valves, again, dual safety measures, but a way to remove oil safely or as safe as possible from the system. For temporary piping, that piping must be supported and have tight connections. That kind of goes into building codes and whatnot, but just in general, they put it here as well. Talking about insulation, insulation is required for the mitigation against condensation frost buildup. There are some exceptions to that. Uninsulated pipes for service are allowed, provided that the vapor retarder is sealed. And if piping or connections are routinely defrosted, pipes may be uninsulated, so you're really referring to like evaporators. But a means of control to drain the condensate has to be provided. So you have to be able to get that water out of there. For foundations, piping, and tubing, this goes a lot into building codes and supports. Supports and anchorage, first subsection. Supports and anchorage must meet building code standards. That's going into your civil design, structural design, and being able to make sure that you're not going to have bending pipes or something breaking, sagging, whatnot. Structural supports must be non-combustible. Again, referring to the building code in regards to seismic joints and restraints. Make sure that's seismically sound. That also goes in for California into your seismic assessment. That gets looked at there as well. So you can start seeing the overlap between all the different requirements that if you meet the requirement one place, you're probably meeting it somewhere else. You just have to make sure you do your checks and balances. Supports and foundations meet or exceed manufacturer recommendations. Skids are in place that they're, usually it's easier just bring them from the manufacturer. Your foundation for your building will support that. Things like that need to be taken into account. And also vibration analysis needs to be taken into account. Doing your vibration analysis and also making sure that the supports and foundation can take some kind of vibration as well. This goes into 5.12, starts going to service provisions. For instance, equipment shall be accessible for maintenance. And this also goes into readily accessible as well. Can your maintenance staff access the equipment without moving a whole bunch of stuff out of the way, without grabbing a ladder, maybe an emergency situation to shut off a valve? Any essential equipment should be readily accessible, and that's really important to remember. So emergency valves, stops, pertinent valves that may be used to close off the system at a certain point, those should all be readily accessible, going back to that definition. Charging connections should be plugged or capped and marked as restricted use. So locked, maybe the valve is locked, the cap has a lock on it, whatever mechanism, a good label on it, whatever mechanism works for the facility that's really called out here. Since that charging connection is going to be opened and closed, it needs to be restricted access. It's usually because it's also easily accessible by just about anybody unless you have some kind of restrictive access on it. The design shall provide for maintenance, functional testing of safety controls. So again, going back to making sure that your maintenance staff can be able to access all this equipment. That also means not climbing over equipment. It's easily reachable, convenient locations for things. Again, going into that readily accessible definition, even though it's not called out here, that's really what they're talking about. Pressure gauges on the high side must be able to display at least 120% of the system design pressure. That means if you're running at 250 psi, you need a gauge that goes up to at least 300 psi. Yes, I did the math for you. So if you have a higher or lower system, just do a quick calculation, make sure you've got the right gauge. You can go a little higher if you want. But you want to be able to see that in case there's an overage somewhere, you want to be able to make sure that everything's being read okay. You don't want to tap out at your design pressure. Manual isolation valves must be available for servicing equipment. Same thing, that everything needs to be accessible for maintenance. It's got to be easily and readily available. For testing, this goes into a lot of the ultimate strength testing. And a lot of this comes from the manufacturer, but as an owner and operator, should always be reminded that you're still responsible. The manufacturer can make a mistake too. So to double check that everything's been tested appropriately, that the minimum testing pressures have been reached. ASME has a lot of a jurisdiction over this as far as what the design is, what they should be tested for. You could start getting into some API standards as well. But basically, your pressure vessels must be designed and constructed to have ultimate strength sufficient to withstand 3 times the design pressure. That's what's called out in the regulation. And that section, if you want to write it down, is 5.13.2.1. So it is in here, and I do have the actual code in front of me. But that's kind of where we're going with this. And again, manufacturer does a lot of this, but it's always good to check your equipment, check that you get all the right forms and the testing and everything else. For pressure vessels, piping, gauges, pumps, and control mechanisms, that's the 5.13.2. They really have to meet the specifications of Chapter 8 through 16. Again, we'll be getting to that in another part. But that's the ultimate strength requirement. The only exception is if they're not called out in the chapters 8 through 16, which is like compressors and evaporators, condensers, equipment like that, your big equipment. What they need to do is they need to meet that section, those 2 subsections listed there, the 5.13.2.1 and 5.13.2.2. And I'm going to start tripping over these numbers pretty soon here. But go read it. It's, again, if you're not designing a new system, you should be okay. It's good to double check. You have your references in front of you. Let's talk about signage. Machinery room signage is actually covered in pretty good detail in section 6.15. Excuse me. That should be the next part of this series. So we'll go over machinery room signage specifically later. In general, caution signs for your ammonia system, the safety diamond being posted in areas where it's pertinent. That's kind of what this standard is getting at under the general terms, making sure that things are labeled. All refrigeration machinery should have labels on them. They should have the call-outs or the equipment call-outs that should also match your P&IDs. Can't tell you how many times I've seen that they don't match up, and they always should match up. Multiple names for things. If the operators are calling a piece of equipment something, but it's different on the P&ID and it's marked different on the piece of equipment, that's not really easy to use. Make sure if that's the case and you have 3 names for one piece of equipment, all 3 names are in all 3 places, and everyone knows what you're talking about. It's really important. Also, any valves required for emergency shutdown should be clearly marked and identified, and that includes the drawings. The guidance on this is, paint the valve red or put a red big sign on it that says emergency valve and the number of the valve. On the P&IDs, color-coded a different color. If you're using AutoCAD, just move it over to a different layer, and you should be able to change the color of that layer all at one time. Pretty easy to do. But that needs to be called out specifically and differently than everything else in the system to make sure that everyone on staff or whoever may be working on that system knows that's an emergency valve. Makes it very clear in an emergency. Again, you're thinking about an emergency. You're working under intense pressure, possibly in a panic. You will revert back to the basic knowledge you have. And so to make it very easy and foolproof is what they're trying to get at. Nameplates. Nameplates really come from the manufacturer. There's not much an owner-operator can do other than double-check the work and make sure everything's here. Each piece of equipment should have a nameplate with the manufacturer's information and design limits. These are more specified in chapters 8 through 16. We'll go through that. This information carries into your PSI. So if your nameplates are faded or whatnot and you don't have the PSI either, how is anyone supposed to know what this equipment is rated for? So it's really important, especially if it's a new piece of equipment, take a picture of that nameplate, put that information in a table somewhere so you can find it easily, or in your PSI section, it should be in there as well. And that way, if that nameplate fades over time, you still have something to go by. And you can reorder these nameplates, but you have to go to the manufacturer to do it. The original nameplate for the pressure vessel should be affixed according to ASME standards. One of the subsections goes over duplicate nameplate requirements. Again, going through ASME standards, where they should be installed, the nameplate should be marked duplicate. It needs to be obtained from the original manufacturer assignee. So all these things come into play. So if you need duplicate nameplates, go see this section on nameplates, and it'll give you all the details of what's required. Ammonia piping signage. This is a big one because I'm sure some of you out there have changed your signage and maybe mixing systems between the old requirements from the bulletins and the new requirements that are listed here, which are not allowed anymore. So if you are using the old standard for your piping, your pipe markings, that's fine, but you need to document it as a facility standard and what you're using for that standard. A copy of the bulletin, and that's what those requirements are, fine, as long as you're meeting them. But it must be documented as a facility standard. If you move to the new standard, and an example is on the slide in front of you, you must use it throughout your entire system. So there is no mixing of systems. It needs to be one or the other. and this standard does allow for a facility standard, which is basically the old bulletin standard. Going through what's required on these labels for the new standard. Ammonia must be on the label somewhere. The physical state of ammonia. So you see those two bars, the orange and the blue, it's liquid and vapor. One of those will be on the label somewhere. The pressure of ammonia, high or low, should be listed somewhere. The pipe service, so in this case, this label came from the thermosiphon return. So that needs to be on there somewhere so that when you look at this pipe, it should almost match your P&ID exactly with the labels as far as what you're putting there. And the direction of flow. These are pretty standard. They're available widely from different vendors. They're pretty easy to find, so it's really a matter of making sure you're consistent throughout your facility. We also this section also talks about wind indicators and that they need to meet the standards in accordance with emergency planning documents. So basically following your EAP or ERP standards on where your windsock should be. Emergency shutdown. All directions for emergency shutdown should be provided where it's readily accessible to trained staff and responders. Again, going back to readily accessible. It can't be hiding on a bookshelf somewhere, hanging it somewhere by a door with like a little letter holder or something. Having it in someone's specific office in a specific location or a drawer or something that you can just grab it and go. Again, you got to remember in an emergency, you're going back to basic knowledge and everything needs to be ready to go, readily accessible. I always say for emergency plans, put the pertinent phone numbers on the front cover. It's, that way they're right in front of you. There's no mistaking what they are. And make sure they're updated. So the drawings and signage for emergency shutdown are listed there. I'm not going to go through everything, but it basically follows what an EAP or ERP should have in it. I know some of the standards aren't as detailed as this is here, which makes this a nice reference. But in general, phone numbers and who to contact and the quantity of ammonia on site and maps and any kind of test pressures that are applied and what's going on with the system that may be important in an emergency, that all should be documented in the emergency shutdown directions. And again, that can go with your EAP as well. This also ties into providing direction to trained facility staff, emergency responders, and coordinating with your local emergency responders. Again, everyone's got to be on the same page for safe operation. For equipment enclosures, basically the enclosure should be suitable for whatever you're using it for and providing protection from physical and environmental damage. There should always be an egress by access panels or doors unless there's some remote service. So it's a bolted system and everything's done by controls. Guarding and barricading is also covered. Going into guards for moving parts, barricades for any equipment that could be hit by a truck or a forklift or any other piece of equipment, and also storing ammonia properly in a proper containment. There we go. For used equipment, did I skip one? Nope, I didn't. Okay, I'm sorry. For used equipment, basically complying with all the standards that were used during the original system. So at least, if not newer standards. So not reverting back to old practices that may be outdated. All equipment should be designed to withstand the static and dynamic loads that are anticipated. Going into illumination requirements for lighting. And that's also covered by a number of OSHA regulations, I'm sure. A means of egress, complying with business code. Again, going back to safe operations, emergency, access to things. It's all coming into these general safety requirements. The 5.17.8 talks about refrigerant piping that requiring signs, insulation, or guards to prevent contact. This applies to piping with an external surface temperature of 140 degrees Fahrenheit or higher that is located outside the machining room at a height less than 7¼ feet above the floor, or anything located adjacent to passageways, aisleways, or walkover stairs. So anything someone could come in contact with, that height requirement is over 7 feet. At very hot temperatures, they need to be labeled so that someone doesn't accidentally put their hand on you know, a hot piece of pipe or something like that. And that is the conclusion of Chapter 5. I wanted to lay out the next few chapters for the next, I'm not sure if it'll be me, or maybe I can talk to someone else into going through some of the stuff so you don't have to hear me this whole series. But trying to get through Chapter 6 through 10 is my goal. This may change as we develop the presentation. This is a new presentation for us, so we're working through it, working through these standards and making sure we cover all the needs of everyone and the really important stuff. But this is kind of the layout, and you can see once we start getting into Chapter 8, we start getting into very specific equipment standards. So, you know, some of this may be a little quicker than other parts. Upcoming webinars and conferences. On September 1st, we have a webinar on compliance audits. September 20th, we have a webinar on dispersion modeling. And I think if I remember right, Alex Mechulev is doing the September 1st. September 20th is being done by Kevin and Vincent here in our office. September 27th through 28th, we will be at Prevention First in Long Beach. Alex and Michael will both be presenting there. In October, 4th through the 7th, we will be at RETA National in Vegas. Come see us. I will be presenting on common deficiencies and what's going on with the regulations and enforcement. October 11th, we have another webinar on security vulnerability assessments. And I'm drawing a blank on who's doing that one. I'm sorry? Oh, David's doing that one. Somewhere in there, we're going to try to get part 2 of the series. It may be after that October 11th. Considering I'm going to start prepping for RETA. So just bear with us, or if you have any questions in the meantime, let us know. We're always open up for questions and try to help everyone through all this. And with that, I will open it up for questions, and as I wait for a couple to come in, I will say that this presentation is recorded and will be available for viewing in about a week or less. We try to get it up in a couple days. Sometimes we have technical difficulties, so we always like to say a week. And my email's on this slide, too, if anyone needs to email me later.
Okay, first we have a comment, and the comment states, IIAR 9 RAGAGEP for closed-circuit ammonia refrigeration systems is presently being developed.
Yeah, well, that came in a little bit earlier, too, and that is under development, so that's why we started doing this presentation, and we're working from start to finish. Hopefully by the time we get to Standard 8, we'll also go over RAGAGEP and what's specifically required for existing systems in RAGAGEP, rather than going through the design requirements and trying to call out important things to note.
Another for your information from the audience. We're told IIAR 1 is presently under review for revision for ANSI periodic maintenance requirements.
Okay, I was not aware of that, but considering the publication we have now is 2012, I'm not surprised that they're moving definitions over. Okay.
First question from the audience. How should I approach RAGAGEP at my facility if I'm just getting started?
So if you're just getting started on RAGAGEP and not sure where to even begin, first thing would be is to assess where you're at. You could go back to the last compliance audit or PHA. That would be a good start. Getting a handle over where your safety deficiencies may be or hazards may be. It may not be regulatory. It may be, you know, a piece of equipment keeps breaking, or your maintenance is just a little under par or whatnot, and how can you improve that? So really assessing what the needs are. From that, going into easy changes or relatively quick changes. You don't have to replace every piece of equipment in your system unless there's a major hazard, but maybe it's just more practice. Maybe you're missing a little piece of documentation. Maybe an update to a procedure will help bring you that extra step forward. So really looking at that and seeing where the improvement areas are. Also communicating with your local agency. Being able to have that conversation with your regulators, really important. I know a lot of people are intimidated, but they really are there to help. They want to make sure they live in these neighborhoods and the communities, and they want to make sure that there's safe operations here. That's their job. So to be able to have that open communication with them going, hey, have you seen anything in the area that I could, that may have happened in another facility I could improve on here, something to look at, something you keep seeing in your inspections that I can assess and see if I have a problem at my facility. Things and conversations like that, things like that are very helpful. I promise you, these people are nice, your regulators are nice, so have a good conversation with them. We have very good relationships with regulators, and they're just people like you and I. They have kids, they have families, and they want to see everyone leave the facility and go home safe to their families. So it's really important to just kind of keep that in mind.
Okay, next question from the audience. This is a statement from the audience. This is in reference to section 5.5.1.4, and the statement says, new low-pressure site equipment connected to an existing system that was in operation prior to the adoption, the design pressure of the new low-pressure site portion of the system shall be permitted to equal design pressure of the existing low-pressure site. It is not must be equal to the design pressure of the existing low-pressure site.
Okay, I'll go back and look at that and see where I went wrong. Yep.
Another question from the audience. Do I have to update my P&IDs to reflect the marking requirements in section 5.14?
We talked about this a little bit earlier. Yes, you do. The P&IDs should always be up to date. So 5.14 was the pipe markings for emergency shutdown and indicating that they are different than other valves. Excuse me. And that should be a relatively easy change. Like I said, if you're using AutoCAD, you can move those valves over to a different layer and make that layer red or whatever color you want, and mark them as emergency shutdown valves. That is very, very important. That should be, updated with your normal P&ID updates whenever you're doing those. Or if you're changing the labeling throughout your facility, just go ahead and update the P&IDs then. At a minimum, those should all be updated by your next PHA because that's a requirement to have updated P&IDs for your PHAs. So just keeping that in mind going forward, that to make time to be able to do that. But yes, the P&ID should be updated with that information.
We have a number of questions and comments.
Okay.
Let me know when we can respond by.
Okay. Yeah, I'll try to take some more questions. We're running close to the hour, but we'll see what we can get through.
So right now I have another comment from the audience. It says, you can put a 300 PSIG design pressure rated vessel on an older 150 PSIG low side pressure rated system and put pressure relief protection to meet the 150 PSIG low side pressure. The vessel could be reused later and put on a future 300 PSIG design pressure system so long as its mechanical integrity is sustained.
Okay. Thank you very much for that. Yeah, we can take a few more. If we don't get to your question, we'll go ahead and respond via email. We have everyone's email and names for this.
Okay, next we have a question from the audience. Are there any sections of the new IIAR2 that will be required of existing systems? Example, signage, emergency procedures that do not require major modifications to equipment to implement the provisions of the new Stand 2?
Okay. That's actually a great question. Perfect example is the signage. The signage is required. Just use that specific example. Like I said, it's the new system versus the old system. So if you have the old system, the effort for RAGAGEP would be, and for the standard, would be to document why you're using the old system as a facility standard, because it does not meet the current standard 2 as it stands. If you move towards standard 2, the effort would be meeting the requirements throughout your facility for the standard 2 signage. Same with emergency shutdown procedures. That, although we talk about it in RAGAGEP's, we talk about it in RAGAGEP terms, however, that's really required and really best practice and ties into PSM and RMP CalARP. So, that's why we wanted to have this discussion. with the second standard now, even though the RAGAGEP Standard 9 is under development, because a lot of this applies, and I would not be surprised if we see a lot of the same verbiage in Standard 9, things to call out in best practice. If you're, again, going back to signage, if your labels are worn out, they're tearing off the piping or whatnot, and you need to replace them, maybe it's a good opportunity to just replace them under the new standard and not have to document the old standard as a facility standard. So it's just keeping in mind some of these items. This also comes into play with equipment upgrades, that a lot of these standards, the standard will apply with equipment upgrades and meeting the conditions of your existing system when bringing in a new piece of equipment. So even though it's not labeled as RAGAGEP, a lot of these items and pieces of information requirements can all come together as RAGAGEP and meeting the new standard. I'm going to take two more if we have. Okay, perfect.
Yes, we do. Okay, so the next question from the audience is there any section that you know of that specifically outlines the required storage capacity of the entire charge in the event of an upset condition? Example, having sufficient vessel storage capacity to pull back the ammonia versus permitting the ammonia to sit out in the system coils or pipes?
I believe it would be, I believe one of the sections calls it out. I can look that up and get back to you. But if my memory serves me correctly, there is a section on pressure vessels, which is where you would revert all your charge back to as like an HPR or something like that. Typically, your HPR should be sized for the entire contents of your system to be able to pull everything back to a single vessel. I don't know exactly where that is, and I'd have to look it up, but I can get back to you on that one.
Okay, we have another question. You mentioned the bulletins are being phased out and the standards in replacement. Does this mean that all of the bulletins will be going through ANSI certification and become more solidly industry standard expectations versus guidelines?
That's a great question, and basically the answer is yes. What IIAR has done is taken the information from the bulletins and put them into these standards and have called them standards now. So the bulletins will no longer be guidance, and that same information and then updated for current practice and safety standards will be in the standards, which will be required as an industry standard. And it's because we're kind of in a gray area and some things are still being developed, and I'm sure they'll be developed and updated more. I know Standard 6 and Standard 9, as we've mentioned before, are still under development and still in public review. So those will be coming out, and those are taking, I believe Standard 6 was going to cover like a lot of the B109, B110 type information. All that information will be pulled into these standards, and it will be a standard for the industry. And again, I mentioned at the beginning, just because they're IIAR standards does not mean they may not be applicable to other ammonia uses. So you could have a power generation or maybe another type of use for ammonia. These standards may still apply by best practice in RAGAGEP just from the fact that you're using ammonia and there are no other standards for your industry out there. So it's really important to remember that. It's very applicable to everybody who's using ammonia. Do we have any more?
That's it. Just some have inquired it.
Okay, yeah, we'll be making the presentation available with recording. Everyone should have received the presentation materials. If you didn't, please email us. We can always send the PDF out again. And I will follow up on that question regarding the charging, the charge holding. So thank you very much for listening, and I hope everyone enjoys it. Hopefully next time you hear me, I won't be sick. So thank you.